Hey everyone, just in case you missed class last week or didn't get a chance to take down a lot of notes, this is a quick screencast of what was covered in chemistry during the third week at PEP. We discussed this notion of working with measurements and mentioned in class that all measurements involve some degree of uncertainty. And if we consider even the most amazing tool that you could use in measuring, it is still impossible, even with the most state-of-the-art tools, to make a measurement of the exact true value of anything except when we're counting. And you know that when you're counting, counting numbers are pretty firm and they're pretty accurate. As I had mentioned, there would be exactly 8 students in a room, not necessarily 7.9 or 7.93 even. So counting numbers are considered exact, but anything that is measured, we know, is never exact. Well, significant digits are the meaningful digits that we use in a measured quantity. And answers expressed mathematically involving measured quantities should have no more significant digits than the starting measurement with the least number of significant digits. And what that basically means is if you are multiplying the value of, say, 8 times 8.316, when you report that, the answer to that, which is going to be maybe around 65 point something, you want to report that so it only has one significant digit, because one of the factors of that product had only one significant digit. So any measuring device, whether it's a ruler, a balance, a spectrometer, or kitchen measuring cup, is limited in its precision, and the degree to which the instrument is subdivided will determine to what decimal place any measurements you take on it will be reported. When reporting measurements, we include all of the digits for which we see a graduated line, and these are certain digits, and we estimate that final digit. And as an example, if you try to measure the length of something using a ruler, such as you see there, we can state a value with accuracy with just this ruler to the whole units level, but we would still have to estimate the 10th decimal place of any measurement made with this particular ruler. If your measurements demand more accuracy, then you could use a ruler, the ruler right underneath, and that one is broken down into 1/10 of a centimeter or millimeters. And if you use that ruler, you can still state a measured value with accuracy up to the 10th level, but you would have to estimate the 100th decimal place for any measurement that you make with that. You hopefully will have already done this lab. If not, you need to get on it. This is, I think it's going to be due Wednesday. In this activity, you're going to measure the 3 geometric shapes that you see there. First, using the less accurate ruler, and I think for my 1 o'clock class, when you come in Monday, I'll give you one of those rulers. And with graduated lines at the whole unit level, and then after you take all those measurements, you're going to use the second ruler with the graduated lines at the 10th unit level. After you take all these measurements as indicated on that laboratory printout, you will then derive measurements for perimeter, circumference, and area. And there are the formulas for those measurements. And you're going to see from this lab, after you get done with this lab, that every measurement does have that degree of uncertainty. And when you report your data, anytime you report data, you do need to reflect that uncertainty. And that's what significant figures accomplishes. The rules for determining whether a number is significant are as follows. All non-zero digits are considered significant, anything between 1 and 9. And zeros, when placed between non-zero digits, are significant. And if you look at that example there, 304 has 3 significant figures. 26,007 has 5 significant figures. And 0.62005 only has 5 significant figures. That 0 in front of the decimal point is only a placeholder. In numbers with a decimal point, beginning with the first non-zero digit, those numbers between 1 through 9, and all numbers including zeros to the right of the decimal point are considered significant. And if you look at that value of 310.00, what that 0.00 tells us is that whatever measuring device was used to make that measurement, it had graduated lines up to the 10th level, and that last zero was estimated. If you look at 4.330, similar case there, whatever you use to make the measurement scale, whatever it is, was accurate and had graduated lines of some kind up to the hundredths place, and that last zero in the thousandths place was estimated. So we would call that significant. On the other hand, the zeros in the numbers 0.000324, which has 3 significant figures, and 0.579 are not significant. They are important because they hold a place. They're only placeholders, but they are not considered significant. And in numbers without a decimal point, where you have trailing zeros, as in the case of the number 1000, those to the right of the last non-zero digit are not significant. Compare the numbers 310 and 4800 to 310.00 and 4800 with a decimal or a point there, as used in Rule 3 above. The zeros in 310 and 4800 are not significant because there is no decimal point following those zeros. So if you look at this, this table here, try to estimate how many significant figures are in each of these measured values. So for 246.32, that's pretty obvious that there would be 5 significant figures. In 107,000.854, there are 6 significant figures there. In 100.3, because those zeros are between 2 non-zero digits, all those zeros are significant there, so there's 4 significant figures there. And in 0.678, that 0 in front of the decimal is not significant, so there's only 3 significant figures in that column. For the number 1.008, again, you have zeros that are flanked on either side by a number between 1 and 9. So those zeros would be considered significant. So there's 4 significant figures there. And in that last value in the column, 0.00340, there are only 3 significant figures, the 340. All the other zeros there are merely placeholders. So for calculation rules, you're going to be performing calculations on measured quantities. When adding or subtracting values, the answer must be rounded to the place value, which demonstrates the greatest degree of uncertainty. And I'll explain that in a minute. When multiplying or dividing measured values, the answer must be rounded to the same number of significant figures as any of the factors having the smallest number of significant figures. And we'll have an example of that as well. Yeah, what does all that mean, huh? So there's 3 problems there. And again, looking back at the rule for adding and subtracting calculation rules, when adding or subtracting, the answer must be rounded to the place which has the greatest degree of uncertainty. So what I would do is I would line, if you don't have a calculator, line all these up, and there's your there's our raw answer before taking significant figures into account. If I take significant figures into account, then that is what all of those values look like. And note that the rounded values represent the limitations of your weakest measuring device, your least sophisticated measuring device, whether that be a ruler, thermometer, a graduated cylinder, scale, whatever it is that you're using. So hopefully in that first column with the number of 169.0, note that that middle value there, 135.0, that is the least accurate of all of those. Well, even though the two values, the one on top and the one on bottom, show much more accuracy, your final number that you calculate has to reflect your weakest bit of equipment, your weakest measurement. When multiplying or dividing significant figures, the answer must be rounded to the same number of significant figures as the factor having the smallest number of significant figures. So 23.7 times 3.8, well, you see that 23.7 has 3 significant figures, 3.8 just has 2. So here again, the 90.06 is a raw number. What I'm ultimately going to have to do, as are the rest of these, is I'm going to have to round these up, or round these so that they reflect the correct amount of significant figures. Whenever you are reporting any final data in any quizzes or examinations that you take, you need to report the final answer so it reflects the proper number of significant digits. But don't forget this. Don't round off digits when you're performing operations with your numbers. Don't round off any digits until you report the final answer. And that's it. Have a great day.